Okay, so now let's move on to the first topic for term 2, geometry. Geometry has many real-world applications, like in carpentry and construction. Okay, and I never understood geometry up until grade 10, because there was a single statement that my teacher showed me that shifted my perspective entirely. That's something that I will talk about towards the end of the course, but for now, let's focus on the basics and defining the building blocks of geometry, like points, lines, etc. In the mind map below, I will detail exactly how I'm going to explain geometry. This is important because after every year, new sections will be taught and old sections will be revised. So ensure that at each grade, you understand each section fully. With this mind map, I will teach you exactly how to solve geometry problems. So it'll be very useful to keep this visual in mind. So if you look at this mind map, we've talked about lines, angles, and triangles at grade 8 and grade 9. And in grade 10, we've introduced polygons. So as you go down this mind map, so when we come to grade 12, polygons, lines, angles, and triangles are still examinable. And the whole of geometry starts off with lines, angles, and triangles. So it's the building blocks of geometry. So therefore, it has to be tested at grade 12. So that's the reason why I want you to understand all of these topics thoroughly, right? And then as we progress, everything becomes easier. Right? But for now, our focus will be lines, angles, and triangles, and polygons. Okay. This is just an aerial view of the main headings that we will cover. You can see that there are not many sections that we will cover. However, the applications are vast. And this is the beauty of geometry. If I have to put it in a nutshell, geometry is just basically made up of these 4 topics. But the applications that we can get from this is vast. And that's the reason why there's not many things that you actually need to know. But we can use this in many real-world applications. So let's move on. Okay, so let's break down the word geometry. And let's talk about the building blocks of geometry, like points, lines, planes, etc. If we break the word geometry, we get geo, which means earth, and metry, which means measure. Euclid is known to be the father of geometry, and this is why we say Euclidean geometry. He was the first Egyptian mathematician who initiated a new way of thinking of the study of geometry. Euclid's definition. Before I discuss geometry, I have to talk about a few basic assumptions and definitions. Use this as an opportunity to expand your mind and learn to look at the real world from a different perspective. As I repeatedly emphasize precision of thought. Eventually these ideas will matter, whether taught at secondary school or not. We will talk about how lines are created starting from its basic element, the point. Lines are very significant because it's the way we read and see the world. Let me give you some examples. Letters are formed from lines, and that is how we read. Lines clearly define boundaries that we should not enter, so do not take this topic lightly. So the mere fact that diagrams are drawn from lines implies that we should not even take this topic lightly, right? It has so much of significance, right? So let's move on to the building blocks of geometry. A point is that which has no breadth, length, or height. It is considered merely for orientation and location or position. So basically, if I have a page and if I have a point, it does not exist. It's merely for reference. It's a way to help us to orientate something in space. Therefore, we say it has no breadth, length, or height. Merely for orientation. So where is that point on the page? That's what the point enables us to do. It enables us to orientate things and place it at a specific location or specific position or orientate it differently, either rotate it or whatever. But without the point, we will not be able to do that. So that's why there's a few basic assumptions that we need to go through in order for geometry to even exist in the first place. A line is a breadthless length. So if you think about this, in 2-dimension, we have two things. We have a length and we have a breadth. But what we're saying a line is, it's a breadthless length. It has only a length. It has only a length. Understood? So there's no breadth. It's so small that it has no breadth. It's only just a single line. It's just a single length. So when you put a ruler here, if you put a ruler here, you'll only be able to measure this part. You won't be able to measure the thickness of that line, because it has no breadth. So that's an assumption that we make in order for geometry to even work in the first place. Okay, plane or surface. A surface is that which has a length and breadth only. So there's a length, there's a breadth. So if you look at a surface, which will be something like this, or a plane, this is a plane or a surface, it has only a length or breadth. We will work a lot with plane and two-dimensional figures. Now, if I have to put this from a realistic standpoint, you know that this is not true in the real world. And the reason I speak about this is that when we consider, let's say, a piece of paper, we think only of its length and width. So if you look at a piece of paper, you think only of the length, left to right, and the width, up and down. However, it has a depth as well, even if it's infinitesimally small. So that page could be like 0.1 millimeters. However small the thickness is, we still have to consider it. And so we come to this realistic conclusion that everything in the real world is three-dimensional. And hence these assumptions are important when working with geometry. So I'm expanding your mind here because when you get to university, we look at things from a realistic standpoint. So having these assumptions down enables us to set the foundation for every other thing that we're going to learn with geometry. Understood? The edges of a surface are lines. So if you think about this edge here and this edge here are made up of what? Lines. And what is a line? It's a breadthless length. So therefore, it just has only a length here and only a length there. Understood? There's no breadth to it. It has no thickness. Collinear points are points that lie on the same line. So if I have a line here, and if I put a point here, and I put a point here, that line passes through both the points. So that's what we mean by collinear points. It lies on the same line. Non-collinear points are points that do not lie on the same line. So if I had a point here, this is non-collinear. So this point here and this point here are non-collinear. They do not lie on the same line. Understood? So here's a visual representation of what we talk about. There's no dimension for a point, and we denote it with a capital letter. With a line, it is one dimension, and it's denoted with capital letters as well. And with a plane, it is two dimensional because it has a length and a breadth, and again, we denote it with capital letters. Okay, so now let's move on to the next part of geometry.